All right, welcome to 9-3. Your you should have this exact page open. So you should have this real number circle in the middle. We're actually going to work through and you're going to fill out the notes that are in here. So the real numbers under real numbers, you would write down the symbols, includes, doesn't include, and so on and so forth. Okay, so we're going to go through these slides. And here's the very first thing you need to write down. Number systems. It says it is a way of classifying different types of numbers. They can belong to more than one type. So it'd be similar to if I gave you a whole pack of random things like apples and oranges and bananas and cucumbers and pickles and onions. You might take that and create categories for them. So fruit or vegetables. Okay, so these are just different ways to classify numbers so that we all know what we're talking about. Okay, if you ever need to pause the video to write it down because it's going too fast, just hit pause. So there's the photo. Notice on the outside, real numbers. And I always get the question, is there such thing as fake numbers? There are imaginary numbers. You probably will go your whole life and never deal with them. You just talked about in university. So real numbers are what we're talking about. You have to split between rational or irrational, so you can't be both. But if you are rational, notice then within that, you could be an integer, you could be a whole number, or you could be natural. Notice natural is the smallest. Okay, so it's the smallest amount of numbers. Whole a little bit bigger, integer is a little bit bigger. Okay, real. So real, the symbols are. It includes all of the numbers. Every number that you are going to come in contact with is going to be real. It doesn't include imaginary numbers. So I did say there's such thing as an imaginary number. You will never deal with them. So don't even worry about them. Some examples, -8. Okay, so negative numbers, 15.2, decimals, 37/5, fractions, and pi, 3.14159, that never-ending decimal. Okay, rationals. The symbol is Q. Okay, that stands for quotient, which means fraction. You should write that down as well. You can't use R for rational because we already used R for real. It includes all terminating. Terminating means it ends. Okay, if you were to terminate something, this means this ends. Or, okay, or and repeating decimals. So it can be written as a fraction. So anything that ends or anything that repeats, we can actually write it as a fraction. It doesn't include then non-terminating, so ones that never end, or non-repeating numbers. Okay, so some examples. 9, 5/6, 2.5, or 8.7. And see how it's got that little line above it? That little line means that it's repeating the 7. I can write that as a fraction. Anything that repeats, I can write as a fraction. Okay, irrational numbers. The symbol is Q bar. So it's got a bar on top. The bar means no fractions. Cannot write these as a fraction. So it includes all non-terminating, non-repeating decimals. Doesn't include the terminating, repeating it. So it's just the exact opposite of rational numbers. Some examples, pi, 3.141, but that's everybody's favorite irrational number. And the square root of 2. If on your calculator right now, if you took the square root of 2, your calculator would say either like it cannot compute it or that it's going to go off your computer screen. So it actually just continues forever. Integers. Symbol is I. It includes all whole numbers, positive or negative. So these are your counting numbers. So -3, -2, -1, 0, 1, 2, 3, 4. So infinity in both directions there. It doesn't include, there's no decimals, there's no fractions. Some examples, -2, +18, -6, 0. Right in the middle, zeros in there. Kind of anything that would be like a temperature, your temperatures that we use. So -17, +52, stuff like that. Whole numbers. Symbol's W. It includes 0 and all the counting numbers, 0, 1, 2, 3, 4, 5. It doesn't include negative or decimals. So all the negatives are gone, and there's no more decimals. Some examples: 0, 1, 2, 3, 4. This is how I tell all my students how to remember. Whole has an O in it, so you know that this is the one that includes 0. Okay, kind of just a little trick. Natural, the last one, the smallest guy, so he's going to have he's more exclusive, okay? He kicks out a lot of the other numbers. The symbol's N. It includes all the whole numbers above 0. It doesn't include 0, negatives, or decimals. So example, 1, 2, 3, 4, 5, all the way to infinity. So yes, the only difference between whole numbers and natural numbers is 0. Whole with O has a 0. Natural has no 0. That's it. Okay, don't lose these notes. You're going to need them. Some examples. Let's name all the sets that the following numbers fit into. Okay, so pause the video, fill these out, see if you get them. Okay, 15. You should have had they're real, it's rational, it is an integer, it's whole, and it's natural. So pretty much all of them on this side. 35/2. He's real, and he can be written as a fraction because he's a fraction, so he's rational. Pi, he is real, and he's irrational. So if he's irrational, remember he can't be any of these. Negative 0.6, he's real, and he's rational because he is a ending decimal, so I could write him as a fraction. But he's not an integer because integers, remember, have no decimals. There you go, practice, practice, practice. And you guys have IXLs in your booklet.